and finding our missing side. And we have to remember that C always has to be our what? The hypotenuse. So like on our first one, we're missing the leg. 9 squared plus x squared equals 11 squared, or 81 plus x squared equals 121. And subtracting 81 from both sides brings me to what? X squared equals 40. And then to get it just x, I take our square root both sides, and I get the square root of 40, which I would not leave. I want to simplify that. So how do I simplify the square root of 40? What perfect square number goes into 40? 4. Yeah, 40 is 4 times 10. So that means this is going to simplify down to 2 rad 10. And I want to have that in simplest radical form. 4 is similar, so I have a missing side, and I'll have 9 squared plus x squared equals 16 squared. And my leg is what's missing. And it doesn't matter if the x and the 9 are flipped around. So again, I have 81 plus x squared equals 256. 16 squared. And I subtract 81. And x squared equals 175. Same idea, I take the square root. Now 175 is not a perfect square, but there is a perfect square number that goes into it. What perfect square number goes into 175? What do you think? 25, yeah, 175 is going to be 25 times 7, 5. Rad 7 is my simplified radical there. And we're going to use that this unit. Okay, we still use the Pythagorean theorem this unit, and many times it's a radical that we're looking at. So we want to make sure we still have that skill. The other thing we're going to be using this unit is adding and subtracting rads together. Really not subtract. Well, you could have to subtract a rad in there. Okay, but this is something we reviewed at the beginning of Unit 8 when we reviewed radicals. And so to add and subtract, we first need to simplify all rads, and then I can only add or subtract like rads. Okay, so I can add rad 2s with other rad 2s, or rad 5s with other rad 5s. So looking at 5, I can't simplify the square root of 6. There's no perfect square that goes into that. So it's still just going to be negative 3 rad 6. Subtract 3. 3 is a coefficient out front. And I can simplify the square root of 20. What perfect square goes into the square root of 20? 4. So 20 is 4 times 5, or this is going to simplify down to 2 rad 5. And so what we need to know is that this coefficient that was out here to begin with is still there. And then when I simplify the radical, I'm going to end up multiplying those together. Whatever I've taken out, it's multiplied by the coefficient that was there to begin with. Okay. And then I have plus 3 rad 5 and negative 3 rad 6. Subtract 6 rad 5. Plus 3 rad 5. I can't simplify this one at all. Okay, there's no perfect square that goes into rad 5. And all I did when I rewrote this is multiply that negative 3 and 2 together. So now that's all step 1. So I simplified the rad that I could. And now I can only add or subtract like rads. So which rads can I combine? I can't combine all of them, but I can combine some of them. Right, so the rad 5s, those are like rads. And so the way that I add or subtract them is really I'm just looking at the coefficients. So if I still have this, negative 3 rad 6, can't do anything with that. If I have negative 6, positive 3, altogether I have negative 3 rad 5s. It's just like if I'm adding together variables. If I have negative 6x plus 3x, then I have negative 3x altogether. I have negative 6 rad 5s, 3 rad 5s, I have negative 3 rad 5s altogether. And then this is it. This is as far as I can go. I can't combine non-like rads. So now that we've done this one, I'm going to give you a minute to look at 6 and go through those steps, because this is probably the thing, we use this a lot, this unit, and it's probably the thing that would have been hardest to do on your own without a little review first. So see if you can simplify 6 and determine what can be combined, and then we'll look over unit 9. Now, let's talk through unit 9 a little bit, just so you know kind of what's to come here. So we're starting with some area and perimeter stuff. You'll notice that the next 2 Wednesdays will be asynchronous. You'll have homework to submit that day if you want to be marked as present, okay? So you'll have homework that you'll get tomorrow. You want to submit that by Wednesday, or else you'll be marked not present on those days, okay? Now, in terms of assessment the rest of the year, this first week is kind of different than what we'll be looking at next week. So we'll, by the end of this week, be doing kind of a review, and it's all area and perimeter that we're going to be looking at. And then we'll take a quiz. Then next week, we're going to kind of continue with this. You'll see we're working on the coordinate plane, but in a little bit of a different way. And then we'll take, after Martin Luther King Day, a second quiz, but we're never going to put that, we're not going to put it together in one big test. They're really kind of separate ideas that are a little bit related, but pretty different in terms of what we're doing. Okay, so we'll have 2 quizzes in unit 9, no test. And then starting on the 20th, you'll start working on your final exam review. And each cohort group will take a final exam. It's a multiple choice. It's probably a little bit, well, it is shorter than normal years because we're taking it in class versus like the 2-hour exam chunk. And then each cohort group on their own will have a final review day. We can ask questions, or we can just kind of go through, make a note card, get ready, and then take a final exam, which again is more like a test. It will be multiple choice. But just kind of, so you know, this is all just for the gold kids. Okay, and then this is for you, final exam review, final exam, and for the remote students. And then this is the beginning of semester 2, is the 27th. Okay, yeah.
Is it gonna be like a Scantron test?
Yes.
How are the goals, or how are the remotes?
Oh, that, well, they'll just have to send me, they can just send me their answers, like they A, B, whatever, and I'll be able to grade that by hand instead. Okay. And make sure on this day, just as, I mean, it doesn't really affect me, but there will be teachers that will want you to do things on this day. I think the idea is that this is like an asynchronous Wednesday for the most part as well, where you won't necessarily be meeting as a Zoom course, but like this day is the beginning of whatever your next semester courses are. So make sure you're kind of prepared to be at least online Wednesday and checking through what they want you to do. So because especially for you guys, because then you may have work to do, right, these days, and then you won't come into your next classes till the week after. Chancey, do you have a question? No. Okay. Did you have a question, Evan?
No.
Okay. So let's get going on some area and perimeter stuff. So if you flip this open, and start with a little kind of basically what we talked about in the warm-up. So our perimeter, distance around our shape. There's 2 ways that we can, in a kind of traditional question, find perimeter. If it's and for today, we're just talking about really not just rectangles, but quadrilaterals. So 4-sided shapes. We're going to look at a parallelogram as well. But if I'm given, so perimeter and area are more difficult if we have to remember the formulas for every different shape. So perimeter and area for a rectangle in a square is different than the formulas used to find, not perimeter, but the formula to find the area of a triangle. There are formulas to find the area of a rhombus and formulas to find the area of a trapezoid. They exist. And if you take the SAT, many times those are things that are like given to you on formula sheets, because once you get to like other shapes, you might not necessarily have memorized those area formulas. We're going to look at area and perimeter a little bit different than the traditional way. So traditional way is what we did in our warm-up. So if I have a rectangle and it's 10 inches by 4 inches, let's say, there's 2 ways that I can find perimeter for a rectangle or a square. One way is to just add it all up. So I'd have 10 plus 4 plus 10 more plus 4 more, right? Just kind of like working my way around That would be what I have all the way around. And I add it up and I say, well, this would be 14, so 28 altogether. Okay, 28 inches. I could also use multiplication and say I have two sides that are 10 inches, plus I have two sides that are 4 inches. I have two 10-inch sides, I have two 4-inch sides. And do that multiplication and then add it together. Still get 28 inches. Okay, so that's kind of traditionally how we went about finding perimeter of these shapes. Two options. Just add it up. Or say I have two of these, two of these. For area, really the formula for area of a square and a rectangle are the same, but sometimes the square formula is just written as base squared, and that's because it's all the same all the way around. So if I have a rectangle, same rectangle, 10-inch by 4-inch, my area is 10 times 4 or 40. What is important here is that we always have units squared. Okay, so for our area, it's always units squared, and we're going to continue that when we look at these grids. And if I have a square, then all my sides are the same. So it may just give me one side, and I can either think about it as 10 times 10, or like this formula says, I can just do 10 squared, or 100 units squared. Okay, so when we don't know the units, we use a U. And we'll be still using the Pythagorean theorem quite a bit, and remembering that this is our hypotenuse. Okay, so that's the stuff we already know. Now we're going to look at finding area and perimeter on a coordinate plane. So each one of our units on this plane, we can count for this one, because it's lying flat on the grid, we can just count. I have 1, 2, 3, 4, 5, 6, 6 units this way. Count the units down. I gotta plug that in or else I'll lose Zoom. I'll be right back. Is it 6? Or is it different? How many units down did you get? How many units down did you get? From R to, oh, what did you get here? 6 units as well. So in many of these questions, it's going to ask you this. Determine if each of the following is a rectangle. Well, it is a rectangle, but is it a square? Like a square is a type of rectangle. Is this a square or rectangle? It's a square. And then find the perimeter and area for the figure. So for this one, I can just use my formulas. So we don't want to, the reason we talk about our formulas at the beginning of this unit is if it's a shape like this, that's just lying flat on the graph, I don't want to forget that I have formulas that I can use. So I know that this is 6 by 6, it's a square. So my perimeter, how many sides do I have that will be 6 units? 4. So I can just do 4 times 6, or I could have done this, 6 plus 6 plus 6 plus 6 all the way around that shape. And my perimeter will be 24 U for units. Okay, we want to have units with our answer here. So since we don't know inches, centimeters, etc., it's just units on the coordinate grid, 24 units. And I can also use my area formula here, where I'm just doing 6 times 6, or my area is 36 units squared. Just using our old formulas that we've learned quite a while ago. Okay. Now, the reason I can do that is because I can evenly count my units. It's lying flat on the graph here. It's really just like above, just happens to be placed on a graph. If you flip this, you'll see that it's not always lying square on that graph, okay? So here we're looking at some different type of quadrilaterals. So we have to kind of think about things in a different way. One thing that changes when it's kind of tilted like this is I can't count units. I can't just go across that and count because I don't know, it's like a slant there and I don't know exactly what the distance is. And it's different here, right, than on this box. So what we do is we're going to draw in some right triangles. Okay, so here's a right triangle in the top and it would be the same right triangle down here. And this right triangle, now I've drawn it square on the grid, right? So I can count the units of the legs of this right triangle. This side is 1, 2, 3, 4 units. Ooh, I wrote a 5. And this leg is 1, 2, 3, 4, 5 units. Same here, right? But good to check that it's actually the same as the other side. Okay, so I have that one right triangle. And then on the other side, a different color of that rectangle, I'd have a different right triangle. And it would have 4 here, 3 here, and same on the other side. So first question, is this a rectangle or a square? Is this a rectangle or a square?
Square.
Well, it would only be a square if I had the same all the way around. So if these were also 4 by 5 right triangles, then I know it's a square. But because these are different, but they're the same, right? So these two sides match, these two sides match. That tells me that this is a rectangle, but I can't go as specific as saying a square. So this is a rectangle. And then to find the perimeter, I need to now use what I know about right triangles to find the diagonal lengths here. So for this one, does anyone know? It's a 3, 4, what would this length be? 5, yeah. I could have used the Pythagorean theorem, but this is a Pythagorean triple. This is a triple 3, 4, 5. Okay, so I knew because I had sides 3 and 4 that the other side was 5, or I could have used the Pythagorean theorem equals x squared, and I could have gone and solved, and I would have gotten my hypotenuse as 5. Now the blue triangles are not 3, 4, 5s. Remember, the triples only work if the longest length is the hypotenuse. So the fact that 5 is on the leg here, this is not a 3, 4, 5, because 5's over here. So to find this diagonal length, I need to use the Pythagorean theorem. 4 squared plus 5 squared equals what squared? Or 16 plus 25 equals x squared, which gives me 41, or that hypotenuse is the square root of 41, okay? Did you track it? It's all in one piece.
Yeah, it's all one.
That's good. Can I simplify the square root of 41? Is there any perfect square that goes into that? It would have to be like 4, 9, 25, then we get kind of too large. No. Okay, so I'm just gonna leave this. If I could simplify it, I would, but I can't. So I'm gonna leave it as the square root of 41. So first step on this kind of tilted over rectangle is I have to find the lengths here. And I do that by using the Pythagorean theorem, finding the missing length. And now I can find my perimeter. And so my perimeter is that I have 2 sides that are 5, and I have 2 sides that are the square root of 41. I have 2 5s and I have 2 square roots of 41. Or I have 10, and I can't simplify that at all. I just have to leave it as the square root of 41 units. And as much as we want one pretty answer for the perimeter, that's all we can do. Okay, because I can't add the square root of 41 to this. Okay, they're not like rads, they're not like terms. We can't combine them. So I just leave my perimeter here. Now for area, I have two options here. So one option we're going to start using more. You'll see we have to use it on the next one. One option is, we know it's a rectangle. Okay, we can see that this is a rectangle kind of just tilted over. We can use area by just saying base times height, or 5 times the square root of 41, which we can't do anything with. We just leave as 5 square roots of 41 and we write units squared. The other thing that we can do, and we end up seeing more and more odd shapes the further we get into this, is by drawing in these right triangles, which I didn't do a very good job down here. But by drawing in the right triangles, you may have noticed that I took this tilted shape and I drew around it what ended up being a square in this case, something that's lying evenly on the graph, okay? And so this larger shape, if I combine the triangles I drew in, is actually in this case a square that is 8 units long here and 8 units long here. So the other thing that I can do, especially when I get to more complicated shapes, is to find the area. I can find the area of the larger square I drew in, and then subtract the area of each of these. So if I find this area, I can then say, well, and I'll take out this and this, or I'll take out 2 of these red triangles, and I'll take out this area and that area, and I'll take out 2 of these blue triangles. Okay, so my other option, instead of using the area formula, is find the bigger shape that I drew in area and subtract the extra shapes. Now, how do I find the area of a triangle? This is base times height. How do I find the area of a triangle? 1/2 base times height. 1/2 base times height here. Okay, so I still need my formulas to complete this. Okay, but if I'm confused, or if I'm not sure it's a rectangle, like down here, this is a parallelogram. We can't use a rectangle formula on a parallelogram. We're going to have to go to this. Then I can say, well, my area here is going to be 8 times 8, which gives me 64. Subtract 2 times 1/2 red. So 4 times 3, base times height, these flat lengths. And what you'll see is we'll get rid of the rad this way too. 1/2, 5 times 4. Okay, and so with our triangles, if we're using this method, the base and height are the straight lengths, the legs, not the hypotenuse. And so what I like to do is clean this up before I rewrite this. So you can either do 4 times 3, which is 12, and then take half of that. Okay, but all of this together is going to be 6. 5 times 4 is 20. Half of 20 is 10. Okay. Or I could have done like half of 4 is 2 times 3 is 6. Or you can kind of multiply 3 numbers together in any order. So then I get 64, subtract 12, subtract 20, or 52, subtract 20, area equals 32 units squared. And it's a much prettier answer, right? So this must be a decimal, but multiplied by 5 goes back to our regular 32, or close enough to. This is going to be kind of a little different looking than what we have here. So what we need to make sure of is that we're only using the formulas for things that are squares or rectangles or triangles. We can't use the area formulas for things that are not those shapes. So what we're going to find on the next one is we have a quadrilateral but it's not a rectangle, it's a parallelogram. And so when we do the area, we have to go to here, where we look at the big picture and subtract the extra. Now again, we need triangles to find the slanted lengths, but I only need a triangle here and a triangle here. For my shape, okay, we're looking for the perimeter and then we'll find the area of this shape. For these sides, for the top and bottom, we can just count units. 1, 2, 3, 4, 5, 6. And same here. But we don't know this length. So to find this length, we will use the triangle, which is 3 units on this leg and 5 units on this leg. And we'll find the missing length by doing the Pythagorean theorem. So for this one, let's see, 9 plus 25 or 34 equals x squared. And so x equals the square root of 34. That's another one that we can't simplify. So I'm just going to put it in. If we could simplify it, we would, but it's just square root of 34. So for my perimeter, again, adding all of my sides, Evan, that needs to go away. I have 2 sides that are 6. Plus, I have 2 sides that are the square root of 34. Okay, there's my perimeter. 2 sides that are 6, 2 sides that are the square root of 34. Or I have 12 plus 2 square roots of 34 units. Make sure you put units or units squared at the end. For my area, I can't, this is not a rectangle. So what I'll need to do is find this, take this larger rectangle that's drawn in, which is 5 units by adding up this whole length, 9 units on the top. Okay, so I have this outer rectangle I've made. So I have, and I like to just draw a visual of that. So I have 5 by 9 rectangle, and I need to subtract out this chunk, this area, and this area, and it'll leave behind the area in the middle. So I'm going to subtract out 2 identical triangles that I have written in red, and that red triangle is 3 and 5 for the legs. So when I write out what I'm doing to find the area, I write the dimensions in. I have a 5 by 9, and then I have 2, 3, and 5 triangles for the legs. And I know that my rectangle is base times height, and my triangle is 1/2 base times height. And I just do the math. So base times height here would give me what for the area of my larger rectangle? 5 times 9, 45. Minus, I have 2, I like to write this one out, 1/2, 3 times 5. Now this one's going to be a little bit trickier, so let me show you how to make your life easier if this happens. Now this is why it's trickier. If I do 3 times 5, I have 15, right? And half of that's going to be a decimal. Now when I'm multiplying a bunch of numbers together, it doesn't matter how I multiply them. Like I can multiply what's inside here, or because I'm doubling it, I can also multiply the 2 times 1/2, the 3 times 5, and then multiply it together. Okay, so when I'm multiplying numbers, you're going to end up in the same spot, no matter what order you go in. So if what I have here for my triangle, if half of it is a decimal or 0.5, then I do, well, 2 times 1/2 is 1, 3 times 5 is 15. Okay, so I can multiply those in any order. The other thing you could have done is 3 times 5 is 15, half of that is 7.5. And when you double it, you get back to 15. It doesn't matter how you multiply these 4 numbers together, whatever works easiest for you, okay? Or I could have said 2 times 5 is 10. Half of 10 is 5. Now I've multiplied those 3 times 3 is 15. However I multiply them together, it should kind of sift out to 15. The area is 45, subtract 15, or 30 units squared. Okay, so this whole, let me go back so you can see the picture. This large rectangle had an area of 45 units, which means there's 45 of these boxes inside that larger rectangle. And what I did is I subtracted the area of these two triangles. And these two triangles had a total area of 15 of these little units inside this grid. And if I take those 15 out, it leaves me with 30 units inside my inner shape here. That's what we're doing. Okay. So you're going to do a little bit of classwork here so we can check ourselves. And there's 3 similar to the 3 we just did. Now the first one's lying flat on the graph, so I'm not going to need to do like subtracting out the triangles. The other 2 are tilted, so I want you to try that, like make a big rectangle or triangle or square and subtract the triangles away to find the area. So the first question it asks for each is determine if the figure is a rectangle. If it is a rectangle, is it a square? It's not necessarily always going to be a rectangle though. Okay, so you're just answering, is it a rectangle? If it is, then is it a square? Okay, so I'll give you a moment to look at this. This is for you to try, and then we'll go over these and see how we did. And anytime your shape's lying flat, you can just use your formulas. When you get to 2, which some of you are working on right now, you need to like draw in your triangles. Let me do it in a color actually. Okay, so you're going to have a triangle here, which is 6, 8. And what actually ends up happening is you get the same over here and the same over here and the same over here. These are all going to be 6 by 8, 6 by 8, 6 by 8. So that means that to find that slant length, I don't have to do the Pythagorean theorem 4 times. This is also a triple, by the way. I just need to figure out once what this length is, and it would be the same all the way around. Okay, does anyone know the triple there? Yeah, 2 times 5. This is going to end up being 10, which means it'll be 10 all the way around. And this is also a square, so I can simplify things a little bit for myself. Okay, and keep going. Look at that last one. Use the area stuff we talked about, but I'm just going to fill in our perimeter here and our area. Oh geez, went too much. This one's a little tricky. It's 1 by 5, this little sliver of a triangle here. And that last one. It's 1 unit long here, and 1, 2, 3, 4, 5. You got to count that last little bit. Get a space. And on that 2 by 10, you get 104 for your hypotenuse, which can be simplified. Okay, 4 times 25 is 100. 4 times 26 is 104. This is 4 times 26, or 2 rad 26 for this side. don't want to run out of time. So let's look at this one for perimeter and area. So for both, when I do the Pythagorean theorem, I get radicals. The 1/5 is the square root of 26. And the 2/10 is 2 square roots of 26. So this one, it's interesting. When I do perimeter, again, I could write them all out, or I can say I have two sides that are just the square root of 26, plus I have two sides that are 2 square roots of 26. And so that gives me 2 rad 26 plus 2 times 2, 4 square roots of 26. And because these are like rads, I can add this together and say that I have 6 square roots of 26 if I do the perimeter all the way around that figure. Okay. I have 1 here, 2 here, that's 3. I'm gonna have 3 more on the other two sides, 6 square roots of 26 all the way around. Area I'm gonna do up here. So for the area, we don't wanna make assumptions that it's tilted, so we don't know for sure that this is a rectangle. We want to use, and also I don't really want to deal with the radicals either. So I'm going to use my rectangle that I've drawn in, and what I have drawn in here, this length, I have 10 units plus 1, or I have an 11 units for my length, and this length, I have 5 and 2, or I have 7 units here for my width of that larger triangle I have drawn in. So I have 11 by 7. And I'm going to subtract out 2 of the triangles that are 2 by 10. And I have 2 triangles that are 1 by 5. So I'm going to find the full area here, subtract that, subtract that, subtract that, and subtract that. And they'll leave me with the area in the middle. And so rectangle base times height is 77 minus 2 times 1/2 base times height minus 2 times 1/2 base times height. Okay, the triangles are, I have to have that 1/2 in there. I get 77 minus 20. Half of 20 is 10 times 2 brings me back to 20. Half of 2 is 1 times 5. Okay. So then I'm going to have 77, and in total I'm taking 25 away from that, which leaves me with 52 units squared for my area. Okay, finding a large area, subtracting out those triangles. Now, the best thing about this week is we're going to change shapes. We're going to change shapes even for 5 minutes or so here. Is nothing changes with what we're doing. Okay, so we're going to take a minute and just look at triangles. We've looked at quadrilaterals, 4-sided shapes. When you flip this page, there's some triangles there. We're going to just look at a couple. I'm not sure if we'll get to all of them in the amount of time we have. Okay, but nothing's changing. Okay, so for a triangle, our perimeter, we're adding up both sides. We already have talked about the area of a triangle, which really that's because it's a 4-sided shape split in half. It's half of base times height. And we'll still use our Pythagorean theorem. If we have a right triangle, which means it's lying flat on the graph, so we know that this is a right angle here, then okay, I can just use my area and my perimeter formula. So here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It's a right triangle, so I can find my other length using the Pythagorean theorem. Which gives me 85. I can't simplify that, so it's going to stay as the square root of 85. Okay, but we already know how to do that. Right triangle should be a gift if you're given a right triangle to find the perimeter and area on. Pythagorean theorem gives me the hypotenuse. Perimeter is the same as rectangles. I'm adding up my sides. So for my perimeter, 6 plus 7 plus the square root of 85. So unlike my rectangle, I don't necessarily have 2 sides that are the same, right? I'm just adding up. I have 6, I have 7, I have the square root of 85. or all together, I have 13. I can't add that with the square root of 85 units. And for my area, because it's a right triangle, I can still just do my formula, 1/2 base times height, 1/2 6 times 7. 6 and 7 are my base and height. Or 3, right? Half of 6 is 3 times 7 gives me an area of 21 units squared. Okay, right triangles are gifts. It's exactly the equations that we've known forever. Now, once we get to non-right triangles, now technically with this one, I could find the height by drawing in an altitude here. But really, let's treat it the same as our rectangles. So to find our slanted length, we draw in right triangles. Okay, to find those slanted lengths, we draw in right triangles. Nothing different than what we just did with a four-sided figure. And so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then this length I can just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 along the top. So how do we find the slanted lengths of those triangles? What do we use? Pythagorean theorem, just like we did with our rectangles. 4 squared plus 6 squared equals x squared. 16 plus 36. 40, 52. What perfect square number goes into 52? Anyone know? 4. It's 4 times 13. Or 2 rad 13. This length is 2 square roots of 13. Find this length. 4 squared plus 5 squared equals what squared? 16 plus 25 equals x squared. 41. Square root of 41. Okay, there's my lengths. Evan, we're not picking up yet. You have time, okay?
Yeah.
So to find my perimeter for this one, it's the perimeter. Just be careful. It's not the outer perimeter here. It's the perimeter of the shape that was given. So my perimeter is 11 units here, plus the square root of 41, plus 2 square roots of 13. Now, none of that can be combined. There's no like rads there, and there's no simplifying that can take place. So for perimeter, I'm just literally saying, these are my 3 sides. None of them can be combined. For area, we're going to go back to what we did before. I have an 11 by 4. And from that, I'm subtracting. Now this time it's different because I don't have 2 of the triangles. I have 1 red, which is 4 and 6. And then I have a blue, which is 4 and 5, which means I may end up with a decimal. I don't here because it's going to divide in evenly. But when I just am subtracting a single triangle and I'm taking half of the base times height, I might have decimals, and that's okay. And so area of my rectangle, 11 times 4 is 44. And for each of these, I just need to remember to do 1/2. So 1/2 base times height, 1/2 base times height, because they're triangles. Or 44, subtract 4 times 6 is 24. Half of that is 12. 4 times 5 is 20. Half of that is 10. Or I have 44, subtract all together here, 22. And I get 22 units squared. So nothing changed, right? And tomorrow, nothing's really changing in terms of how the strategy works. We don't have a time to do our last triangle today. I'll just kind of show you from last year. Okay, the last one was just, they were all tilted, but same idea, right? So I draw in the triangles, and then I got to find the slanted length to write out my perimeter. And then to find my area, I take my big rectangle, and I'll have to subtract triangle 1, triangle 2, and triangle 3. And that'll leave me with the inside area. Okay, and that's what your homework is tonight. You do have homework on this tonight that we'll look at tomorrow. It has both 4-sided shapes and 3-sided shapes, okay? And I'll probably give you a little bit of time to finish that up tomorrow at the beginning of class. Okay, thank you for letting me keep going. I know we got close to the end there.